in this video, we'll be making the environment actually look a bit better. So even though this wasn't there in the part one or episode one, I've decided to make it look a bit better. So we can actually tell it looks more professional now, and we can actually see good graphics and we can understand it. Otherwise, it was orange on orange. The agent was orange and the background was orange, so it wasn't that good. And now it just looks a bit more professional. So to make our environment look better, what we're going to do is first we're going to increase the room length. So we're going to set it. We're going to multiply it by 2. So instead of 54, or yeah, instead of 52, we're going to say 104, and that will automatically calculate that. But what we're going to do is we're going to take this grid line definition here, the grid columns and grid rows. We're going to delete that and we're going to put it at the top like this. And then instead of room length divided by 9, we're going to do divide by grid columns. So since we're going to increase the number of columns, and then we're going to say grid row, and then room width is block side length divided by grid rows. And then what we're going to do is we're going to say the wall color. So the color of the wall will change it. So it will be, instead of orange, we'll make it a kind of off-white, which will be 0.707 and then 0.703 and then 0.75. And then the floor color, we're also going to change that a bit. We're going to set that to 0.345, and then it's going to be 0.345 again, and then it's going to be 0.364. These are just different colors, so you can change and you can do whatever you want with this. So now instead of color.black for the background, as you saw, we're going to make it a kind of blue. So we're going to say a vector 0.4, 0.6 and 0.8. That's how that's going to be. And then we're actually going to we're going to add a ceiling here, as you saw, because we're going to add lights. So for the ceiling, we'll say self.ceiling. Self.ceiling equals another box. The position is a vector of 0. So the x-axis is 0. Self.room height. And then again the z-axis is 0. The size will be a vector of self.room length. And then in the y-axis it will be 1. And then the z-axis will be self.room height. And then what we'll say the color is the self.floor color, so they're matching. So instead of self.room height, we're going to actually say the room width instead of the room height. And then since these are all actually reflective, they kind of reflect the light, we're actually going to make them kind of matte. So we're going to say shininess, which is the property. So you can set the shininess, that will be 0, and we'll set that for all of these. And we're also going to set it for the ceiling. So that's that. And then to create the light, we're going to actually define a light object here, or we can just go ahead and run this. And you can see, yeah, it looks almost kind of better now. And then we're also going to obviously change the grid color. So we're going to define a grid color here. So the color, because we want to just be able to change it once. So it's going to be a vector of 0.11 0.98 and zero point 0.5. So here in instead of color dot white, we're going to say it's going to be grid color, and same here, just like this. Now if we run this, so it's kind of a green. Yeah, you can see it's a greenish. And then we're going to actually increase the width or the radius as we've defined here. So we're going to make it 0.05, so it'll be a bit thicker, like this. And then what we're going to do, we're going to change the height to, we're going to change the height to 40. And then now we're going to actually define a light class. So we'll say a class light, and then we'll define the constructor, which is the init function. So we'll also take a position and the size. So we'll say the self dot pos equals pos, self dot size equals size, and then the self dot light color, so the color of the light. So you can obviously have white, you can have blue, something like that. So we're going to say that's another vector. For me, it's just going to be kind of off-white, so it's going to be 0.85, 0.9, and 1. And then over here, we're also going to import something called local light from vpython, just like this. And then we'll say the self dot panel, because local light, it just creates light. It creates a point source of light, but we want it to actually look like a light panel. So we're going to self dot light. We're going to self dot panel. So that will be another box, obviously, because you saw it was a square kind of. So the position equals position, size is the size, and then the color is the self dot light color, and then emissive equals to, basically that says it kind of emits light on its own, but it doesn't emit too much light, it doesn't like reflect that much. That's why we have another local light. So we'll say self dot intensity, that will be 0.2, so we can change this and increase the intensity. So the self dot light, that will be the a local light. Position equals self dot position, but there's actually no size, just the self dot position equals position. And then instead of intensity, we're not going, there's no intensity. We're just going to make, instead of color equals that directly, we're going to say a vector of self dot light color dot x times self dot intensity, and then self dot light color dot y times intensity, and then self dot light color dot z times intensity. So that's actually going to create the light, and then that's the entire light class. And then now over here, after we define the ceiling, we can create a list of lights. So we're going to say self dot lights, that is going to be, or we can say self dot light panels, that will be a light object. So we want to place one, we want to place both of them in the middle. We're going to create two, both are in the middle, and you can see they're kind of like at 2/3 and 1/3 from the side. So we're going to say the position equals a vector, that will be negative self dot room length by 3. So we're dividing the room length by 3, so it'll give us 1/3, and then negative means it's in the negative x direction. And then the y will be self dot light height. So we have to define that right now. And then we'll say the z is 0. Then size is obviously, size is self, and then the size equals self dot light panel size. We're also going to define this. And yeah, that's all. And then we're just going to create the next light object. So that'll be, the position will be positive, it's a vector, the x-axis is just positive, self dot room length by 3, and then the y-axis will be self dot light height, and then the z-axis will again be 0, and then the size equals self dot light panel size, just like this. And then now we're going to define these constants up here. So we're going to say after the room height, we'll say self dot light panel size. So that will be a vector, and there will be 5 in the x direction, 0.6 in the y direction, and 5 again in the z direction. So it'll just be a thin cube, kind of like that. And then the self dot light height. So that will just be the self dot room height minus self dot light panel size by 2. So basically light panel, because when we say the light panel size is here, if we set a position is wherever, so the center of the light will be at that position. So actually there will be half of the y-axis size, so at the bottom and half at the top. So we're going to say it's in the middle, which means the self dot room height minus self dot light panel size by 2. And then we'll just that should be all. Now we could run this and see. Okay, yeah, so actually we need to say dot y, because it's in the y direction. We're not going to do the entire vector. So yeah, it's like this. You can see it's not emitting any light right now. We'll see why, but you can see at least there are some light panels here. And then now what we're going to do is we're also going to say the grid columns will be 14, and will be 6 grid rows. And we're also going to say here, we're going to say self dot lights. No, we're going to say self dot scene dot lights. So the default lights, we'll set that to 0, so there are no lights. I mean, we'll set that to an empty list. And then the self dot scene dot ambient lighting, we'll say that's color dot gray, it'll be 0.6. So now you should be able to see a bit. We'll restart it. Okay, now we'll try. You should be able to see the lights. Yeah, you can. So for some reason, we're still not seeing the lights, and we'll see why that is. So there's actually light shining, but since we've set all of the sidiness to 0, it's not reflecting. So for the background or for the back wall, we can set it to 0.1. So now you can kind of see the light reflect. Yeah, you can see here there's light coming off here and it's reflecting, and you can see the reflection spots here. And then we're also going to change the color of the countdown timer. So here we define the countdown color. So the countdown color, instead of black, we'll make it a vector. So point 1, point 3, and point 5. And then the timeout color, instead of color, again, we'll make it a vector. It'll be 1, point 2, and point 2. So it's kind of red. So now when it times out, yeah, you can see now it's kind of a bluish black. And then when it times out, it'll go red. So you can see it went red, but here we have to say in test.py, we have to say if timeout, we'll just sleep time.sleep for a second. So that way we can actually see when it hits 0. So you saw there it hit 0, and then the 0 was kind of red. And then now the last thing we're going to do before ending this episode, we're going to create hexagons on the wall, as you saw in the beginning. So we're going to define another method here. We'll just get rid of this test method here, and we'll stop calling it here also. So here we'll define a new method. We'll say, so here we'll say def. We'll create a new method underscore create. I mean, we'll say draw a hex wall. Actually, we'll say draw hex wall. So it'll take the wall object. It'll take the wall. Well, like type as in like is it a back wall, side wall, like that. And then what we'll do here, we'll say that wall type is by default back. Here we'll say r equals self dot hex size. So we have to define that now. So we'll go up here. We'll define self dot hex. We'll also define two more things. We'll say self dot hex size. So for me that will be 7. And then we'll say the self dot hex color. The color is a vector, just zero point 0.6. So 0.6, 0.6, and 0.6. Then the last thing, the self dot hex lines. Basically, it's a list of lines that we're drawing to create the hexagons. And then we'll come back down here. We'll say the hex h is the square root of 3 times r, and then the x spacing. So the spacing of the x between, I'm pretty sure it's the horizontal spacing. That will be 1.5. 1.5 times r actually, times r. And then we have to import math here. So we'll say from math import square root. And then we'll say the y spacing is the just xh, which is the height, basically the height of the vertex to vertex, basically is the height of the hexagon from vertex to vertex. Then we'll define some safety margins or whatever. We'll say the horizontal margin. So that will be r plus 0.05, 0.05, and then the vertical margin will be it'll just be 0.05. And then so we'll say if wall type, so if it's a back wall, what we'll do is we'll say the wall width equals the wall object dot size dot x, and then the wall height or h will be the wall object dot size dot y. And then we'll say the left side is the, or the left starting point will be the wall dot wall object dot position dot x minus the wall height divided by 2, and we'll rename this to wall w instead of wall width. And then we'll say the right is wall object dot position dot x plus wall height divided by 2. The bottom is wall object dot position dot y minus wall height by 2. And then the top of the wall is the wall object, so here we have to put a dot, wall object dot position dot y plus the wall height by 2. Then we'll set a fixed z, so we're not going to move the z, so fix underscore z, that will be the wall object dot position dot z plus, so if we put it directly at the wall's z location, it will be inside the wall, so we want to extend it outside a bit, so because we want to be able to see it inside, so we want to extend it a bit outside of the wall. So we'll say plus wall object dot size dot z, z divided by 2 actually. And then the origin in the x direction, so for column 0 the origin will be kind of left, which we define here, left plus the horizontal margin, and then the origin y will be the bottom, not this, we'll also add, we'll add the hex height divided by 2, and then we'll add the vertical margin, and then the number of columns, so we'll just estimate them, or we'll overestimate them actually, because when they go outside of the wall we want to cut them off, so we don't want to underestimate it, otherwise it won't fill the entire wall, so we'll slightly overestimate it, so that'll be the max, it's the max function 1 or an int, we'll convert this to an int, and then we'll open another pair of brackets, we'll say the wall width minus 2 times the horizontal length, or yeah, horizontal margin divided by the x spacing, and then we're going to add 4 like this because we want to overestimate it. Then for column in range num columns, we're going to say cx, so column x equals the origin x plus column times spacing, so I'm x spacing, the row is 0, so we're on the first row, and then we'll define a while true loop. We'll say the center y, center will be the origin y plus the y spacing times the row, so whichever row number we're on, and then we're going to also add 0.5 times the y spacing, 0.5 times the y spacing if it is an even number column basically, so we'll say, or if it is an odd number, so if col divided by, I mean mod 2 equal 1, which is basically if it's an odd column number, otherwise we'll do 0, we'll add 0 otherwise. And then we'll say if the center y minus the origin y, or no, we'll say if the center y minus the hex height divided by 2, so if that's greater than the top plus vertical margin, basically if it's higher than the wall height. Okay, so we'll, yeah, if it's higher than the wall, so we'll say we'll break. So if the center, basically if the center is too far above, so we'll break it. we'll break the loop actually. So import pi here. So from math, import square root and pi. And then after that, we'll say the points. So it's a list for a hexagon, we have 6 points. So for I in range 6, because again there are 6 points. We'll say the angle is pi divided by 3 times I plus the hex rotation. And then we'll say the raw y, or the raw x actually, is the column x or cx plus r times the cosine. So I have to import cosine of the angle. Then the raw y is the center y plus the r times the sine of the angle. So we'll also up here we'll import a cosine and sine. So this will give us basically the raw x and y, and then we'll clamp it to the wall. So we don't want it to go outside. So clamp to the wall rectangle. So we'll say clamped x. So the clamped x-axis will be the minimum of the max. So we'll say raw x and then left, and then in the minimum we'll say right. And then we'll say the clamped y is again the minimum of the max of raw y and bottom, and will in the minimum of the minimum of top. So it's compared to top, and it's like the minimum value. And then we'll say the points dot append. So we'll append a vector, clamped x, clamped y, and fixed z. And then we'll say points dot append. So in outside of this for loop, we'll say points dot append points 0. So we'll just append the starting again. Then we'll say self dot hex lines dot append. So we'll append a curve. The position is points. The radius, for me I've chosen 0.05, and the color is the self dot hex color. And then we'll say row plus equals 1. So we'll increment the row number. Otherwise, so this is if the wall is back, otherwise else. Since we know what the walls will be, it's either the back or it's the side. So since we don't have the front wall and stuff like that, so we'll say the wall. So this is obviously it has to be the side wall in this else statement. So the wall W equals the wall object dot size dot z actually, and then the wall height will be the wall object dot size dot y, and then the front will be the wall object dot position dot z divided by the wall width divided by 2, I mean minus the wall width by 2, and the back will be the wall object dot position dot z plus the wall width by 2. The bottom will be wall object dot position dot y minus the wall height by 2, and then the top will be same thing but instead of minus plus. So this time we have a fixed x because it's the side wall. So it'll be wall wall object dot position dot x. So we'll add the wall. So we'll actually open brackets here. We'll say wall object dot the size dot x, and we'll divide that by 2. So let us if the wall object. So let's if the wall object dot position dot x. So in the x-axis, if it's less than 0. So since the back wall, we didn't do this in the back wall because the back wall is obviously in the negative direction for us. But for the side wall, if it's a right wall, it'll be in the positive x. If it's a left wall, it will be negative x. That's why we want to actually check which side it is here. Since we're not providing left or right wall, we're just saying side wall. So if it's less than 0, otherwise we'll say negative self dot, or not self dot, we'll say negative wall object size divided by wall object size dot x divided by 2. And then what we're going to do, we're going to say the origin z will be the front plus the horizontal margin, and the origin y will be, it'll not be this, it'll be the bottom plus the hex height divided by 2, and we'll add to that, we'll add the vertical margin. And then the number of columns will be the max of 1, and the int, we'll open another pair, we'll say wall width minus 2 times the horizontal margin divided by the x spacing divided by 4. I mean plus 4 basically. And then we'll say for column in range num columns, we'll say the column z, so cz, that will be the origin z plus the x spacing, so times the column. Then the row equals 0. Then we'll create another while true loop. We'll say the center y, so that will be origin y, and then we'll add plus y spacing. We'll multiply by row and we'll add a 0.5 times the y spacing. We'll just do this basically. We'll add 0.5 times the y spacing if it's an odd number row. So if row modulus 2 equal 1, otherwise we'll be adding 0. And then we'll say if the center y minus the hex height by 2 is greater than the top plus vertical margin, we'll break out of this while loop. And then we'll say here in the while loop, itself, we'll say hex rotation. That will be pi, we'll open brackets here. It'll be pi by 3. So again, if the row mod 2, if that is equal to 1, so if it's an odd number row, otherwise it will be 0. And then again we'll define points is another list, and then we'll say for I in range 6, because 6 points in a hexagon. So for I in range 6, we'll say the angle equals pi by 3 times I plus the hex rotation. And then the raw z, this time the raw z will be the cz plus the r, which we defined all the way at the top, times cosine of angle. And then the raw y will be the center y plus r times the sine of the angle, or yeah, the sine of the angle. And then again we need to clamp it to the edges of the wall. So we'll say the clamped z equals the minimum. It will be the minimum of the max of raw z and the front, comma the back. And then the clamped y will be the minimum of the max of the raw y, comma bottom, and then yeah, top, like this. And then we'll say points dot append, we'll append a vector clamped, and we will say, so this is, we have a fixed x, so we'll say fixed x, and then we'll say clamp y and then clamp z, like this. And then outside of this for loop, but still in the while loop, we'll say points dot append points 0, then self dot hex lines dot will append another curve. The position is points, the radius is 0.5 or 0.05, and then the color is self dot hex color, And then finally we'll say row plus equals 1. So this will create a hex on the wall, and obviously we need to call this function here, draw hex wall. So we're going to call it just before setting all these things. So just after setting hex lines, we'll say self dot underscore draw hex wall. So we'll say the self dot, the wall object is self dot back wall. So first we'll draw the back wall, and then the wall type equals, or we actually don't have to specify anything since it's a default value. Then self dot draw hex values, we'll do the left wall type equals side. So it's a side wall, and then we'll do the right wall, and the wall type is side. So now if you were to run this, it should draw hexagons on the wall. Okay, so we have some sort of, so you can see it's drawing properly here, but for some reason it's not doing it here. So we'll see why that is. This should not be wall height, this should be the wall width actually. So now let's try it, let's see if it works properly. So in the wall type equals back. Yeah, now the back wall is proper, but we need to fix the side walls. So we still need to see what's happening in the side. So since the back wall is proper, which means this entire if statement is proper. So we don't need to check this if statement. We just need to check the else case. So this is not a plus here, it's supposed to be times. So I accidentally put r plus cosine angle in the while true loop. So now we'll try it. And we still have some, it's kind of working, but they're overlapping. So we need to see. So over here, instead of row modulus 2, it's actually column modulus 2 in the while true loop, the first line in the while true loop. So now, yeah, now you can see it works. And we have that reflection as you saw in the back. So that's the actual design on the walls. There's just one more thing I want to do. Can you see the, yeah, so it's not properly aligned. This countdown, it's the countdown is not properly aligned. So when it gets to 2 digits, then it kind of comes over here to the right. But when it gets to a single digit, it kind of comes towards the left. So you can see here, when it gets to 15, it's over here. So I want to center that. So to center that, what I'll do is, I'll first close the script. And what I'll do is, over here at the top, in environment, in the init function, when defining the countdown position, what I'll do is, the countdown text position will first, will start at -7. So I found that for the size of the text that I have, -7 is good for 2-digit numbers. They'll appear in the middle if the x-axis is -7. But when it's a 1-digit number, what I want to do is over here in the update countdown function. Yeah, in this update countdown function, I'll actually say the countdown. So after defining the countdown text, I'll say the self dot countdown text. After defining this dot, the countdown text actually will say position dot x, so the x position of it. So if it's a 2-digit number, we want to make it -7 because then it'll come in the middle. But if it's a 1-digit number, we're going to make it a -3, so that single digit will be almost completely in the middle. So that will be -7, and we'll say if the length of countdown text, if that's equal to 2, otherwise it will be -3. So since here we'll only be having 2-digit numbers for the countdown. So if it's a 2-digit number, then the x position is -7. Otherwise, if it's not a 2-digit number, since we will only have 1 or 2 digits in my example, so we have to assume it's a 1-digit number. So then the x position will be -3. So now if we run this, you should see, yeah, now it's exactly in the middle. And then when it gets, yeah, so now you can see even though it came to a single digit, it's still exactly in the middle. So that's it for today. In the next video, we'll be making the agent, and maybe we'll be making the pressure plate or something like that. But that's it for today. Okay, bye.